Thank you for joining us today. We're here for a short presentation on the future of wireless for healthcare delivery organizations. I am fortunate to be here with my friend, Shawn Jackman. Shawn is an incredible individual who has been a phenomenal volunteer as well with the Health Technology Alliance. Shawn is currently the founder and CEO of Clinical Mobility, and he also serves as a member of the Health Technology Alliance Steering Committee. He founded Clinical Mobility in 2015 to help advance wireless reliability and security for HDOs. He previously managed national wireless design standards and solutions for the nation's largest HMO. I should say my name is Tammy Koikowski. I'm the Director of Clinical and Informatics for HIMSS. It is my responsibility to manage the clinical communities within HIMSS and to connect with other organizations. HIMSS is proud to be partnered with the Alliance for
the Clinical American College of Clinical Engineering. And Amy. So I never can.
Amy.
Yeah, there you go.
A lot of acronyms going on around here today. And the three of us have been together for approximately 15 to 17 years now in an effort to advance our operations together. They're incredible organizations. They provided phenomenal partnerships in working together. So our mission is to provide this collaborative environment for the health technology management, the clinical engineering community, and the healthcare information technology community. And so within this framework, we have developed a couple of opportunities to work together, present together, and to provide some networking opportunities to connect our three organizations together. So within that, we also distribute a monthly e-news. We do have a website. We are currently in development on some toolkits and additional resources, and we do have several educational webinars that we produce during the course of the year. So we have found that the reason that we wanted to get together is because we had several challenges that faced the industry, and through this collaborative network and collaborative opportunity and bringing subject matter experts together from the three organizations, that we can collaborate and be more effective together. We do have some future focus of our organization where we are trying to work together to provide some opportunities to continue to educate, to support the workforce, and to support the industry overall. Truly a great opportunity for us to help affect the area as a holistic approach rather than individually. We just think we're better together.
Absolutely.
This was me. I apologize. That was in a different order, but it's a pleasure to be with you today. I'm going to turn this over to Shawn Jackman.
Well, thank you. Is everybody can hear me? Okay. Huge crowd today. Anybody wants to learn about the future of wireless in healthcare, please join us. So Shawn Jackman has no or apparent conflicts of interest. This is kind of a standard slide in these presentations, but I wanted to put a spin on this that this is not a sales presentation by design. Oh, thank you. I get the chance to advance the slides too. This is all about education. HTA, the Healthcare Technology Alliance that Tammy did such a great job introing about. It is all about education for our healthcare industry, and that's what you're going to get here today. So, to the point, 5G, we're all hearing so much about. Wi-Fi 6, 6E. This is a new variant of this Wi-Fi 6 technology that many folks haven't heard of. So I'm going to be covering that today. And another new technology called CBRS. It goes under different names, but I'll tell you a lot more about that. And specifically, the areas that I want to cover here is, understanding the true business perspective around these technologies. I'm going to give an overview of each one, compare them, so you can kind of understand what it's good for, or what they're best suited for. Let's put it that way, and how excuse me, how healthcare is going to benefit from them. And again, I promise no hype. Right? This is just information. It's all education. That's what we're all about. We hear about wireless and we deal with it every day, but I wanted to ground us quickly from a business perspective, because it's easy to lose sight of the most important aspect of everything we do with technology. It's why are we doing it? And in this case, what problem does wireless solve? Sounds pretty trivial, right? We think about, we use it every day. But I want to kind of rewind our thinking here a bit. When we think about digital health, digital health has changed just about every aspect of delivering healthcare. Right? We couldn't really operate facilities the same way. We can't provide care the same way. There's so many advantages and things that open up with new use cases. Now we've made it digital. So I contend that digital health would be compromised without mobility. Caregivers inherently are mobile workers. Another question to ask is, what is the most important objective to achieve when deploying any wireless solution? This is from the behalf of the HTA, and I'll tell you, as a practitioner of working in healthcare IT, this really, when you really boil it down to it, when you achieve reliability, you also achieve safety. And when we have to have that in mind when we're deploying technology in healthcare. If we achieve this, so many of our other goals are met, by doing so. I'm going to come back to this slide, so I don't want to dive into this, but I'm just introducing it, and I want to start to compare. These are some of the areas that I'm going to be addressing, giving you an overview of each technology. First one is I'm going to cover CBRS, and then 5G, and then Wi-Fi 6 with this new variant of Wi-Fi 6E, where it's operating at 6 gigahertz. First one, CBRS, there is an OnGo Alliance. That is the industry consortium that really is focused around introducing CBRS. It's kind of like the Wi-Fi Alliance, or 3GPP, in Wi-Fi and the cellular world, respectively. You'll hear this term, the CBRS, then you'll hear this sometimes. You might hear, I heard a cool one today from one of the vendors, 5G LAN. I thought that was a great name because what we're talking about here is a private cellular technology. So cellular, we use it as consumers every day, right? LTE, 4G, 5G, those technologies. The carriers operate those technologies. They're the ones that provide those to us. And now, this technology is going to allow a hospital to deploy their own cellular network. So think about it as their own 4G or 5G local area network. It's private, it'd be enterprise managed. And the cellular experience, you can gain a cellular experience with a Wi-Fi-like cost structure. Wi-Fi is relatively easy to deploy. You run it's something that usually goes in the ceiling, and it just has a unshielded twisted pair cable, not very expensive cable that runs back to a network closet. And you can just keep expanding the network, with that. And this is going to work very much like that. And there's some interesting, it's a new technology. That's why you haven't heard a whole ton about it, but you will. And that's why we're including it today to intro this. There will be some opportunities to enhance indoor cellular coverage and performance specifically. There's some security benefits, etc. So I'll go into that. So again, this CBRS is really the name of the wireless spectrum that the FCC has categorized this space, and it's this 3.5 gigahertz band. It's about 150 megahertz of real estate. And I'll tell you what's significant in the wireless world is when we get the opportunity for new wireless spectrum that we didn't have before. That's when a bunch of things can change, and that'll be a theme, as you're going to hear throughout this presentation, is around some of this new spectrum that's coming at us, and then what are we doing, what are our opportunities to deploying it. The use cases, this is, again, early, but the ones that are targeting, because we've been working with some organizations, and these are the ones they're targeting. And they've come out of studies around use cases. So clinical communications, what do I mean by that? I mean the applications that go on smartphones that are being deployed for clinician communications, so voice, clinical alerts and alarms. and messaging. Even video is coming as well. So it's great use case or application for clinical communications. Internet of Things, so think about the facilities and the sensors and those kind, and maybe it's a vendor operated system. Here's a segmented network. There's some opportunities with security to get them off of Wi-Fi and onto something else. And then this is a little bit, excuse me, a little bit more forward-looking around indoor carrier coverage, and I'm going to talk about that a little bit more. But medical telemetry, we have this band called WMTS in North America, or in the FCC domain, and it's only in the North America, the FCC domain. And it's where you can put physiological monitoring devices, telepacks, we've referred to them as, and organizations have, when they use WMTS, they put a parallel infrastructure up. Well, I'll tell you from somebody who used to run networks and have to build those out, and IT is being thrown at you all day long, you're trying to eliminate extra overlay networks. So when we have a chance to do that, we want to take advantage of it. And here's, I think, an incredible intersection or an opportunity for a use case. Why CBRS? This is a bit of a marketing slide that I unmarketized, if you will, or made less salesy, and I want to put the claims that the vendors in this space will tout. And I, as somebody who's objective about the vendors and even the technology, there's a point to be made pretty strongly around all of these. Reliability, I'm not going to go into all the details, but it's new spectrum, it's a parallel network, it's using a very mature protocol, it's using LTE and 4G, 5G technologies. So you can get actually a big improvement in reliability. The way quality of service works, it's far more advanced than the way it works on Wi-Fi. Security, it's sort of nothing new here, but in the cellular world, you have a SIM card that goes in your devices, and that is your credential for how you connect to the network, and it's leveraging the same mechanism. So nothing, drastic here. Mobility, what I mean by that is, roaming throughout a building and kind of transitioning between infrastructure elements as, to carry on your conversation, is definitely superior to how Wi-Fi works today. It's a lot more mature in the cellular world. Coverage, it's the way, some of the underlying details of how it leverages the wireless spectrum and the power that's allowed, you do get a far bigger coverage zone. And it has device density benefits as well, meaning you can have a lot of devices on each radio. And some battery life benefits, which we all like, right? It's how good is technology for clinicians if it's dying halfway through the shift. Right? So there's some good, nice improvements there. I'm not going to go through this either. I just want to provide a background. So anytime you get new spectrum, this stuff has all been used. Like, we don't have any spectrum left. It's all about how do we reuse the spectrum that's been allocated for, frankly, a lot of military uses that's been using most of our electromagnetic spectrum, wireless spectrum. And these were what we call the incumbents. So in the 3.5 gigahertz band, these were the incumbents. And you had some military, ground-based radar, some satellite communications, some of the wireless broadband, utilities will use it. So I'm not going to, again, go through the details, but when you have incumbents, which every wireless spectrum does, the new technology that comes into it has to figure out a way to cohabitate with it. And I guess the point is, these are the things that that all of the standards are designed to work in concert with. So what does it look like when we deploy it in a hospital? So this is what it would look like. And they have these things you probably know as access points today with Wi-Fi, but they call them CBSDs with CBRS. And they hang on the ceiling, they go back to a wiring closet, nothing new there. What is new is this stuff, very new. It's a whole new world full of acronyms of which healthcare IT, or enterprises in general, no clue about. It's a whole bunch of things. So the market, all the vendors in the space that are selling this technology, Their challenge is to take really a cellular technology and to make it friendly to the enterprise. And there's some of them that are saying that's going to be our claim to fame, right? And that's what, I would say, I would argue is, if I were to be asked by a hospital, do you think we could take this on and deploy this? And I would honestly have some questions whether it makes sense to do this. But I think it's going to get more and more simple over time. But just know that it's an entirely new world. But this stuff looks very much the same. So bottom line, CBRS. It's new. The use cases are emerging. We covered those earlier. It has the potential to replace DAS. DAS stands for Distributed Antenna Systems, and you'll see antennas all throughout that are kind of cabled back to an infrastructure that cellular is deployed that way in hospitals today, where the carrier plugs into this DAS, probably in a basement somewhere, and it's carried out through the antenna system. And most hospitals have to pay for that antenna system themselves. There's other needs for it, but largely the spend around DAS is because you have to support indoor cellular. Well, if that goes away, this can get incredibly cheap, maybe even go away. People will argue these points, of course. There's always cases where things can change. For hospitals, you can actually potentially convert the CBRS infrastructure into a monetization opportunity where you can allow the carriers to roam to your network by having, there's companies that are focused on those agreements to make this possible. The hospitals this is the hospital's network, it's not the carrier's network. So the control has flipped from the carriers to the hospital IT teams. So you control it, and you could actually put your own cellular devices. So you can go buy a smartphone, take a SIM card, and plug it in, and it's connected to your network, just kind of like Wi-Fi, but it's using this separate network. So CBRS, that's the bottom line with that. Let's go to 5G. We hear a lot of marketing about 5G. I frankly get upset when I hear half of the marketing, because it's a bunch of BS. When you really get into the argument and the details, they want us to believe it's the next best thing and they're going to solve all world hunger with it. And as an objective person, I see some wonderful things coming from it, but where they take it a little too far. It's important to know that 4G is, I'm generalizing here, but I've been in the room with these carriers, and their 4G networks are pretty heavily saturated and utilized, so they have to do something here. Well, and then in the meantime, there's been some incredible technology improvements in radio technology, where, if we can deploy 5G, we're going to get the benefits of all that new technology, and we can, start moving people out of 4G into 5G. The healthcare benefits, though, in my professional opinion, the benefit is not for in-hospital. It's for the telehealth, it's the remote use cases, and where's healthcare going? Well, healthcare is going more and more remote, more and more into the home. Think about a physician that's having to do a remote visit. They could be at home, they could be wherever. Well, 5G is going to help that, and to make that experience better and more reliable. And connecting, if you have a faster cellular network that everybody's using, and that's connected into a fast internal hospital network, you've removed bottlenecks. But just know, we don't deploy this stuff in healthcare. Carriers do. We have zero control. For example, if somebody dropped a phone call, running 5G, who are you going to call? You're going to call 1-800, I don't want to pick on any carrier, right? But pick a carrier name, and they'll answer and they'll say, okay, what do you want me to do about that? Right? But there's no, it's a technology that's available for, all kinds of wonderful benefits, but it doesn't have the same kind of, we can't offer the same levels of SLAs and what as we can if it's a technology that we're managing ourselves. So the carriers run this. Spectrum. I put this up because people tout this millimeter wave stuff. So there's really think about 5G, there's two chunks of radio spectrum to leverage. There's what we're all used to today, call this mid-band, if you will, that is kind of the same chart down here, and the demarcation point is right here where we start getting this millimeter wave. This stuff, not very useful. There's touted, oh my gosh, we could do incredible speeds with this. Yeah, but there's a reason why nobody's used it today. It doesn't penetrate from the outside in, at least very well. So there's some arguments that people say that try to do that, right? I'm just trying to be objective as possible. Huge challenges with this. Your hand can even block the signal. Your head can block the signal. This is a very complicated technology to use. It's going to be used for backhaul between maybe cell towers. It could be to maybe a building. You want a remote building that wants to be connected with 5G. Great use of that spectrum. Not for our handsets and not for our devices we're carrying in our hands. Way too challenging. That's where this is going to be used. And you see the carriers spend billions of dollars for this spectrum. And you see kind of all these different chunks all around that are being used, and it's licensed. Some of this stuff was 3G spectrum. But 3G is now getting, I don't know if you've heard some of the carriers say, yeah, your 3G device isn't going to work anymore. So you have to come in, we have to give you, you're going to have to replace that device, aka my dad's old flip phone, or something like that, right? Those old devices. Well, because they own the spectrum, and what they want to do is turn off and unplug all the gear that serves 3G, and they want to use that same radio spectrum for 5G. It's actually the right thing to do in so many ways. This is the prized spectrum, is the stuff in the space. And that's why you see some of this rebanding and some of this stuff going on. Anyway, high level, hopefully that was self-explanatory. So how do you get it for a hospital? And you deploy it, to deploy it inside the hospitals, you could potentially plug it into your existing DAS if you have one, but you probably have a ton of upgrades that are required. So a bunch of capital expenditures to make that happen. And the cellular carrier still has to bring some equipment to you to plug into that, so there's cost for them as well. It's not just your choice, right? You have to meet in the middle. Potentially, excuse me, CBRS-like deployment, where it would be like a CBRS deployment that was for one carrier. Then a separate set of CBRS APs, like APs, if you will, for the other carrier. But this also relates back to, if you're a hospital, you put your own CBRS network in, you could potentially get 5G and work with the carriers in that roaming agreement. So that would be the third, I guess I didn't put here, but where there's potential. So bottom line, you're getting a big improvement in the macro network. That's the stuff outside the four walls, at home, while you're driving to work and back. Not incredibly different from the 3G transition to 4G. You're like, wait, what are you saying? This is like, I've been told by every 5G commercial, this is like the best stuff. Well, I mean, when you really break it down to it, it's making a better 4G network. But that's what we got when we went from 3G to 4G. We had a way better 3G network, and it is a much better 4G network. But it's not. I mean, just trying to be real. There's a lot more hype, sizzle than steak, if you will. But benefits, very much so, with telehealth and some of our remote use cases for healthcare. Big advantages. So I'm very bullish on 5G. It's just I'm just trying to temper the line on what's being said and marketed. How many? Well, there's not many people here, right? So Wi-Fi 6E. It's a new variant of Wi-Fi 6, and I'll get into that as a detail here. So a little history of Wi-Fi. I'm not going to go through all this, but you probably remember back in the days when things were really slow, 802.11b, A, and G. But look at the dates. Then really, around 2009, 802.11n came in. That's when speeds really became, so we don't have a speed problem anymore. We had other problems with the protocol. But then you look at the speed jump here, right? So if there were people arguing, say, yeah, there's a speed problem, by the time you got to here, okay, there's no speed problem. But we still had other issues, and namely around device density. So if you have an access point here, the Wi-Fi access point, and you have like 50 devices deployed, things really get crummy pretty fast. And that was really the core focus of Wi-Fi 6, or in other words, 802.11ax. That was the problem, the primary problem to solve. I mean, there were some other benefits because radio technology just improved, so we got more speeds. And now, so Wi-Fi 7 is off in the future. I'm not going to talk about that today, but there's a new variant of Wi-Fi 6, which is the 6E, that a lot of what I'm focused on today. So the key attributes, it's very cost effective at scale. It's effectively free from an endpoint perspective. It's the path of least resistance. Wi-Fi is in practically everything we buy, even the stuff that doesn't move. This TV right here, I've got money on the table that this is not a mobile TV, but there's probably Wi-Fi in it, right? Like all the ones at home. So you almost get it as by default. And here's a thing that's been good and bad about Wi-Fi. Backwards compatibility sounds great. Well, not when you have a bunch of brand new devices that are capable of, and I'm going to go back to this. Let's say you have a bunch of these devices, but you've got some of these still running on the network. Well, the problem is the Wi-Fi backwards compatibility kind of has to penalize these and make them work at kind of the lowest common denominator. So the backwards compatibility has been brutal for us in the Wi-Fi world over the years in terms of gaining some of these benefits. It really kind of stinks at doing roaming, and you're talking to somebody who has spent most of my career in Wi-Fi, so I'm being just very transparent, right? This is the engineering problem that really we have to focus on when we deploy big Wi-Fi networks. But it's as compared to CBRS. There's ways to make this work really well. It just takes a lot of engineering. It's how we connect indoors by default. In our home, in our offices, in the hotel you're in, even at this conference, there's Wi-Fi networks. So one of the first questions you ask, how do I connect to the Wi-Fi network, right? And in hospitals. It's how we pretty much do, it's the default answer of what we do inside hospitals. Again, I've got technical content up here. I'm trying to not go into any of that stuff, but there's a couple of visualizations that I think is important. To give you an idea of what is changing with Wi-Fi 6, and with this new 6E variant, is we're gaining all of this frequency spectrum that we never had before. And you look here, so 2.4 gigahertz, we've all have those at home. There's really only 3 usable channels. And if we got to do a big one, the 40 megahertz channel, you only have 1. That stinks. Right? But we go to 5 gigahertz and we got more channels. We receive more channels, right? So this first block, we're called Uni 1 and 2. Then you have this Uni 3. And a whole bunch of Wi-Fi devices don't even support this in the middle. So we almost, from deploying in a hospital, we generally only ever deploy these 12 channels, maybe even 8 if we run into radar issues. You see this DFS thing. So I'm showing a picture, gosh, I mean, there's a decent amount there, but in reality, we couldn't even use all of this. The stuff in the middle, not every device supports this. Because of this backwards compatibility, when they were issued, this spectrum came later. It started off with just this and this. Well, what they're doing with 6 gigahertz, it's really changing, learning from those mistakes. And I'm actually, frankly, pretty excited about this. I mean, you look at how many channels we can have. I mean, it's silly. We have more than we'll ever, frankly, need. So we can go wider. The benefits of going wider is our speed increases and our throughput increases. But look at this. It's a massive chunk of spectrum. 1,200 megahertz of spectrum. That's 1.2 gigs with 59 channels. But you can start grouping them into 40 megs or even 80 meg channels. In healthcare, we're probably going to be, we're definitely not going to be here out the gate. And I'm saying that based on that's where all of the infrastructure manufacturers are focused. Probably here, maybe 80, but certainly 40. And I just want to compare the regulatory domains. So here's the FCC, North America. This is what FCC adopted. As of the time of this presentation, ETSI was still only ratified this part of the spectrum. They do have more countries to coordinate with and a little bit more complicated. The industry is hopeful that we're going to be able to get a compatible chunk. But we look at it from the FCC perspective, 3 times more radio spectrum than we have today. And this other little thing, I talked about some of the quirkiness of that 5 gigahertz, and I'm going to go back to it. I said we couldn't quite use all of this, and we had some different compatibility things. One of them really had to do with power, and uniformity across the entire spectrum. So that's all getting cleaned up. All right, deploying Wi-Fi inside hospitals. I mentioned this earlier, but it can be a science project. There's a lot of reasons why some of these clinical communications deployments or large device rollouts have a lot of challenges, because it'll expose all of the problems you have with your Wi-Fi network, and it's usually around roaming and some of the latency issues, and if it's not deployed right, you'll experience those problems. It's capable of not having any of those problems. It's just, again, it's kind of a science project. Healthcare IT teams are in full control of this. They deploy it. They can do data collection on this, so they can, they can troubleshoot it. Like when a physician has a ticket or gets or talks to one of the IT people and say, "Hey, I dropped a call," you can actually go figure it out. All of the capabilities are there, so you can get quick resolution. You're not dependent on anybody. Something that, generally speaking, the healthcare IT community really enjoys is having at least the chance to be successful within their own control. Wi-Fi is kind of, the protocol has been a little sloppy historically, and if I say uncoordinated, when you compare it to cellular is very coordinated, strictly coordinated between the mobile device and the infrastructure. And you have a little bit of, again, I'm not going to want to get into details, but a little bit more uncoordinated. 6 gigahertz, it's not quite out yet. You're going to start seeing consumer devices. So if you had a hospital that you had to go live with in 3 months, buy the regular Wi-Fi 6. Don't worry about the 6 gigahertz. I mean, it'll be great to have it, but Wi-Fi 6 technology as a whole is fantastic. You'd still be, again, you can always be optimal, but can you solve all your business problems with Wi-Fi 6 in general? Yes. So don't let this worry you. But you will be deploying it at some point in the future, I would imagine. Bottom line, deploying Wi-Fi, it's unavoidable. It's in everything. Every hospital has it now, so it's a must-do. It's had a bit of a checkered past, but it's really, I'm hoping that I've exposed some elements to this that has proved to you that it's mature, that it's been maturing. And there's a whole bunch of things I didn't get into. I'm just trying to keep the high level. And the reliability improvements have gone from just abysmal to, actually, we can really achieve high reliability with Wi-Fi today. We really, truly can. And it's just going to even get better with Wi-Fi 6. 6E. Okay, next slide. Here we go. So I'm going back to the chart now, and this is the last slide. You could argue this. Some vendors are going to say, no, we're cheaper, no, that's, yeah. I get it, right? But I'm trying to be very, as objective as truly as I can, because I don't care, what technology or what vendor's product you do. In my career, I focus around solving the problem and helping the customer be successful with it. So, high level, from the spectrum, we went over this. You can see kind of where they sit. The usage, this CBRS, I don't know if I mentioned this, but you can get a license for it. So there is which means you own even that wireless spectrum. Nobody else can share it with you. This is fully licensed, and then you get into Wi-Fi is fully unlicensed. That's been one of the knocks. Like if you're selling this stuff, you're like, oh, this unlicensed stuff is. Well, turns out we've been pretty successful with it. Device populations, there's hardly. There aren't many CBRS devices today. It's changing quickly. All of the big carriers want this in every one of the new mobile phones. So you're going to see a lot more here. Device population, about medium support. Not every, even mainline smartphone. If you have a relatively new smartphone, it may not have 5G. If you buy one brand new today, sure, right? It's in everything coming out. And then Wi-Fi, again, it's like everything's got it. And Wi-Fi 6E is starting to ship, so my laptop I use, it comes with Wi-Fi 6E. Cost to deploy, again, arguable points. This is a little TBD because CBRS is still pretty new. But I think it's going to be pretty low. Actually, maybe even fairly competitive with Wi-Fi. because some of the technology here has actually gotten more expensive, and that's because it does more, right? And there's other features and software licenses. But 5G, this is for the carriers. This stuff costs a fortune, and they not only buy the spectrum, it costs a fortune, but their gear is very expensive. Reliability, it's a little TBD, but I really do believe it's going to be have really good reliability. 5G, again, it's a macro network. It all depends on is there coverage in your area, right? We know what this is like as a consumer. That's not going to change much. Then you get into Wi-Fi that it could be really high, could have a lot of stars, or it could be down to 1 star. It all depends on who implemented it and how it was engineered. Complexity, I'm giving it a little bit of a bad score here because of that core. There's a whole bunch of new things that it's not quite ready for the enterprise, in my opinion, for them to manage it all on their own. I think there's still a role for vendors that are going to have to play if you're going to deploy CBRS in the short term. I think long term, the focus is to make it just like Wi-Fi in terms of complexity. Again, carriers only almost doesn't matter, but Wi-Fi is, every IT team knows how to manage that. So that's it.